So today is lesson 2 of our winter 2020 mean stack course. We played around with some really basic files last week. We looked at how to run a node server using the command line. We talked about blocking and non-blocking code, synchronous and asynchronous code. In a really non-technical description, what's the difference between those two? We should all be clear on this by week 2 of Node. In its simplest terms, what's the difference between synchronous and asynchronous code? Arya?
Synchronous code will stop, process something, and then continue on towards that process, the function, I guess.
Yep.
And synchronous code will process that function, but continue on. Sorry, asynchronous will continue on and process other parts of it.
Exactly. So in synchronous code, only one thing can happen at a time. If our file needs to do 3 different things, item number 2 can't start until item number 1 is finished. In asynchronous code, we can start our first process, and if that process, while that's executing, we can do other things. So we can have multiple things happening in parallel. And JavaScript uses this funky callback syntax to allow our code to return to a process when it ends, but while we're doing other things in the meantime. I'm just going to open up our files from last week briefly. Actually, you know what? I can just open it up on GitHub. Suppose I want to just open up the our non-blocking file that we did. So we talked about a couple of the syntax elements last week. I want to review them, but also try to go over them for a little more clarity. So in this method here, we're reading a file from the file system. And here we use this anonymous function, a function that has no name, and it's passed as a parameter to our read file function. So this function, this coding style is called a callback structure, where we pass one function as a parameter to another one. And this structure is the key to Node's asynchronous ability. Now, there's one other sort of unusual structure here. We used it, we didn't really talk about it, but I want to talk a little bit more about it and explain how this kind of plays into how Node works. Notice on line 5, we actually have the word food used twice. The first instance where you see it on line 5, what's the purpose of it here? What's happening? The word in front of it should be a clue, right? Yeah, it's a variable, right? We're creating a variable called food, and we're assigning it to be equal to the result of this asynchronous function. Yet over here, we're reusing that same variable. So we've never really seen this before, or at least I assume you've never seen this before in any code you've done. Create a variable and then use the same variable for some other purpose in the same line of code. Seems kind of bizarre. And it is bizarre, but it has a specific purpose. So this structure where we create a variable and then we can also use it here in the same line is what's known as the structure is called a closure. And we should talk a little bit about what a closure is. I know this is kind of a little bit of theory, but it will help explain some of the funky syntax we're going to be working with all semester. Probably a good idea for us to try and understand why we're using this different syntax. Why don't we just use traditional JavaScript syntax that we already know? So the idea of the closure is the idea of a closure is it's really a wrapper around a function. And we need this wrapper in Node for 2 reasons. And we'll try a couple examples so you'll see what I mean in a minute. The first thing is this wrapper is what allows the callback to happen. This is what allows us to pass one function as a parameter to another one. It also affects memory use and how variables are used or reused. Okay? And we'll try a couple examples so that'll try to illustrate this. So I've put a link up on Blackboard. I'm not going to read all of this, but there's a good kind of walkthrough here. So I would suggest when you have some time, this article isn't very long, but it's worth reading through. The author does a really good job of explaining the structure and how it's used. A few of the things aren't super relevant to what we're going to do, but a couple of the examples she's got in here, we're going to do together, and we can walk through line by line so we can kind of see the difference between a traditional plain JavaScript structure and using a closure, and why we would want to use that closure structure when we're using Node. Okay, so that link is here. She's got some code samples from GitHub. And Douglas Crockford, who was actually the original developer of JSON, he said that basically closures are the whole key to modern JavaScript. We're going to write ES6 or above. We're going to see closures everywhere, and that's how we harness its power, really, and its performance. So I'm going to create, go to my folder where we created our files last week. So you can create them anywhere you like. But last week, I suggested you create a node directory in your root user, and I had created a lesson 1 folder for last week, a winter 20 lesson 1. I'm going to create a new folder for this week. You can save it anywhere you like. This is a convenient location because if I open my command prompt, this is where this is the default path it'll open to. So I'm going to make a new folder here. I'll call it winter 20 lesson 2. Soon we'll make one folder and we'll keep working in that same application for many weeks like we did last semester, but not quite yet. We're still kind of just building a few individual files for a few weeks. So then I'm going to open this folder in Webstorm and we can create some files in here. Or you can go right through your code editor and create a folder anywhere you like in here. Call it anything you like, doesn't matter. So when I open up Webstorm, I'm not going to update it right now. I'm going to cancel this. So it defaults to the last folder I had open, which was our lesson 1. So I'm just going to click on File and Open. And I'll just browse to my new, I want to open my empty lesson 2 folder instead. If you want to put your files in the same folder as last week, that's fine, up to you, no big deal. We're just creating some individual files again for now. And Webstorm, if you're using Webstorm, it said, do I want to open it in a new window? Meaning keep lesson 1 open and also open lesson 2, or do I want to just do it in the current window? I don't really need the stuff from lesson 1, so I just closed it. If we need to look at any of our code from last week, we've got it on GitHub anyway, we can reference it. So I just have an empty file. So I'm going to make a new JavaScript file. Actually, okay. We'll call this one Closure Example 1. Again, file names here are not really important. So if you want to name the file something else, that's fine. So we're not going to write any asynchronous code or deal with a callback here. We're going to just look at its most basic level, what does a closure look like? So let's create a simple JavaScript function called parent. We're going to create two functions that are connected. We'll create a parent function and a child function. So in here, we'll create a variable called message, and we'll set it equal to hello world. Now, JavaScript allows us to nest functions. We can create a function inside of another one. This parent may have many children, so we want to execute a function repeatedly for every child. So in we'll create a nested child function. Our parent function creates a variable. It has a function that lives inside it. And then when our parent function gets called, the parent function should call the child function. So we would need one more line. If we want to run this code, what would we need to do? If we loaded the file right now, actually we can try it. If we load the file, try and run the file right now, what will the result be? Right, why will nothing happen if we execute it at this point? Right, but which function haven't we called? Right, we've never called the parent function. So this is set up, but nothing actually happens. It never gets executed. We can try it. I can write the command node and closure example 1. Execute the file. I don't need the extension. If I try this, right, there's no response. There's no error, but nothing ever actually happens. Because we've set up a function, but we never invoke it or execute it. So what would we need to do? So I'm using the Webstorm terminal. I know not everyone is using Webstorm. So if you are using Visual Studio Code, you would need to open a command prompt into your folder. So using your Mac terminal or your Windows command prompt, browse into your folder and just run the command node space and whatever you've named your file. So what would I have to add on line 15 where my cursor is blinking in order for this code to actually run? It's in the file, but it's not being, like it's on the team, but it's spending the whole game on the bench right now. How do we put the player into the game? Right, so we just make a call to parent. So now our function from line 2 to 12, that's creating the function, and line 15 is saying, okay, go ahead and execute now. And down here, I'll show you a little, there's a shortcut with the command window. I can retype that command, or if I just hit my up arrow on my keyboard, it will repeat the last command I ran. Probably a lot of you already know this. If you didn't, there's a shortcut for working in your command prompt. If I hit the down arrow, I've only got one command here. So it'll normally cycle through the last several commands. So if we run it now, what result do you expect to see in the terminal? Ian? Yeah, it should now print our hello world. So it creates our function. We created a function. We're creating a variable. So how does this work? The variable's created inside the top level function. How is it that inside the child function, we still have access to that variable. This is one of the important points and the reasons we use this closure structure. Right, it's about the scope of a variable. Can you explain a little bit more?
Variable message and the function child are both siblings of the same, sorry, children of the same parents.
Exactly, you're right. So we declare the variable on line 4. That means we can use it here, but we can also, that variable will keep its value in any kind of nested function. And this is important for a few reasons, and we'll see as we're going to do a few more simple examples. So this is one way we could write this code, and there's no callback, there's no asynchronous code. This is just plain old JavaScript, where one function lives inside of another one. Any variable in the top function. So in effect, the parent is really, this is our closure structure. It's a wrapper that lives where the child function, lives inside of. And any variables in that wrapper are available in the child. I'll try and give you context of when we might use this in a real world web application. Okay. So let's think of a website that does event, where it's like an event management website, people like an Eventbrite, right? Or a meetup. So people register for events. And then shortly before that event is to take place, so we've got a database, we have a list of all the people who've registered for that event. We want to send reminders, right? 2 days before, hey, your event is coming up. And in that email, let's say we all sign up for that same event, we're all going to get the same email, right? So there's a whole body of email, like a header with a logo, there's signature, and there's content, and all that stuff is going to be standard. We're all going to get the same email. And even if we register for 2 events, most of that email is the same, right? The top of the email, the bottom, and there's standard text, your event is coming up. Except some parts of the email are going to be different. What parts of the email are going to be different if you register for 2 different events? Right, the name, the date, the location. So there'll be some dynamic content that has to come in here. So we might have this parent function that might set up the static part of the email content, right? Here's the header with the logo. Here's the footer down at the bottom. But then inside, we have to, for every person registered, we have to maybe show their name in the middle of that message. And dynamically, we have to show when is the event and where is it and what's the name. So we're going to want to repeat some of this many, many times. And other things like the message header and footer, we only need to set that up one time. We don't need to reset those same variables 1,000 times. We can set them once at the top and then populate the individual information over and over again, send the message. So that would be an example where we're using some kind of closure. Right? We have one thing that needs to happen once, and that one thing, that one event has information that we then need to repeat and do something different multiple times. Would be one example. So this is one really simple syntactic way of structuring it. We're going to write a similar example with a slightly different syntax. Again, we're not using callbacks, but it will look a little bit more like we did with Node. So we'll make another example. And then we'll probably take a break, and then we'll do 2 examples that come out of that tutorial on closures. So I'm going to make a new JavaScript file, and I'll call this one closure example 2. In this case, we're basically just going to rewrite this exact same code, but we have a bit of an alternate syntax we can use to do the exact same thing. So first, we'll create our closure or wrapper function. So again, we'll create a function called parent. And we'll create the same variable we did before, and as Arya said, that variable is scoped to the closure, so it can be accessed anywhere inside this function. Exact same code we already wrote so far. Now, in our first example, we execute the child function here. I go back to example 1, we then just call the child function. We're going to do it a little bit differently here. So our parent function is actually sending back the child function. So our parent object, rather than executing the child function, it sends it back. And then we execute it. So this is a little more similar to what we did in our non-blocking file, where we assigned the variable food equal to the result of a function. If we run this, I'll run example 2 instead of example 1. All right, in my coverage. Oh, sorry. No brackets here. Sorry, that's the problem. If we have the brackets, our child function executes here. We don't want it to execute here. We call the closure first. The closure gives us the child, and then we execute the child. So we get the same result. So first we get back the child function, and then we execute it. So we're assigning a variable equal to the result. This syntax is a little closer to what we did in our non-blocking.js. Now, it's not, I realize it's not readily apparent from these examples why we would use this structure instead of using this structure. They both kind of do the same thing. Our first example seems simpler. There's no, in this context, there's no real benefit to writing the code this way yet. So what we're going to do, we'll take a break. We're going to do 2 more simple examples, again, that come from that tutorial. And those examples should help illustrate why this syntax, what the benefit of this syntax actually is. We can't quite see it yet, but we will when we start changing some of the variables. And also talking about how memory is allocated for functions and variables, because this affects how fast our site runs, especially when we have lots of users and lots of requests. Okay, so this is just kind of step one. This isn't really a fully complete example. This is just introducing the idea of what a closure starts to look like. I know it's sort of confusing. That's why I'm going to strongly recommend you do take some time later or before next class and have a read through this tutorial. It's quite accessible compared to some of the other stuff around closures. So we're going to do some more on this. Does anybody have questions so far about the two examples that we've done? All right, why don't we take a pause here? We'll come back to this after we have a little break. Okay?